Welcome back to Chapter 4, where we're looking at the periodic table. Recall in our last section that we discussed the development of the periodic table, emphasizing Mendeleev's and Moseley's role in the formation of the modern periodic table. And then we moved into the organization of the periodic table, where we examined rows being periods and then columns being groups. Today, in this section, we're going to look at the classification and characteristics of the elements. The question we want to be able to answer is, how does an element's position on the periodic table affect its properties and its chemical behavior? As you can see in this colored periodic table, the majority of the elements are metals. We're going to talk about metals, metalloids, and nonmetals. You will also be coloring the mini periodic table that's located on the back of your copy of the periodic table. And if you wanted to get a jump start on that, you could go ahead and get that done. On your notes, you might want to go ahead and outline each of the sections because it didn't print very well, very clearly, so you can't see, for instance, where the metalloids are compared to the nonmetals. As mentioned in the previous slide, the majority of the elements are metals. There are 4 properties of metals that we have to know. Metals have luster. What that means is they're shiny, especially when they're polished, so they like to reflect. Metals are also excellent conductors, so the material will allow heat and electricity to flow through them. Metals are ductile. That means that the metal can be drawn or pulled out into a wire, but they're also malleable, which means it can be hammered or flattened into different sheets, into thin sheets. Also, metals like to lose electrons in order to achieve stability. When they do that, they form positively charged ions. We actually call those positively charged ions cations, and this will be the topic of our next chapter. Stability is when an atom has a full set of 8 valence electrons in their outermost energy level, and it's actually called the octet rule. So metals, they tend to have loosely held valence electrons, and so if they're held loose, then it's easy for another element to come and snatch one from it, to grab one. So luster, excellent conductors, they're ductile, and they like to lose electrons and form positively charged ions. Those are the 4 properties that you're going to need to know for your test. There are 4 specific categories of metals that we're going to discuss today. And then there's like the other metals. So we'll start with the alkali metals. That's the group 1A elements, except for hydrogen. Hydrogen is not a metal. So the alkali metals, they're the ones that are in the far left of your periodic table. They're very soft and they're shiny. So they're so soft that they can easily be cut with a knife. They all have 1 valence electron, which we already know because they're in group 1A. They easily lose their 1 valence electron to become a positive ion in the formation of a stable electron configuration. Remember that a stable electron configuration means that the element's outermost energy level is full, so it has 8 valence electrons. And if you'll look at it, it has 1 valence electron. So if we lose that 1, then the next inner ring becomes the outermost energy level, and it's full. So that makes sense. This group of elements is extremely reactive, especially with water. Now, we did a demo in the beginning of the year when we were talking about matter. And this was the element that exploded when I placed it into the water. These elements are never found alone in nature, so they're most generally going to form compounds through the losing of that one valence electron. And obviously, it's going to contain the most reactive metals, francium and cesium. These are located towards the bottom left of your periodic table. Lithium is the least reactive of the alkali metals, and trace elements of lithium are found in water, soil, and rocks, and it's used in all types of batteries, even your cell phone. Sodium and potassium are the most abundant of the alkali metals. Think of salt and bananas, very prevalent in our life. And cesium and francium are the most reactive. Group 2A elements are known as the alkaline earth metals. These are the elements found in the Earth's crust. They're silver colored. They're still a soft metal. They're slightly less reactive than the alkali metals. They have 2 valence electrons, and they have to lose both of them to get to a stable electron configuration, so that requires more work. Once it does that, it becomes a 2+ ion. They are known for their colors. They're found in paint and firework. Most don't melt in fire, and so these were classified as the earth. So in your readings, you might see them referred to as just the earth metals by the Greeks. And again, they're usually found as compounds, not alone in nature. Several of these are important elements, like mineral nutrients. They form mineral nutrients such as magnesium and calcium. Calcium is found in bone. It helps you to build dense bones, and it's found in milk. In the last set of notes, we talked about the Group B elements, the transition elements. They consist of the transition metals and then the inner transition metals. The transition metals are hard and tough metals, and they form colored compounds. They tend to be pretty unpredictable, and most of them can form variable numbers of bonds, up to a maximum of 3. And that depends on the element with which it's going to react, or whom it's going to bond with. This is the least reactive group of metals, and is most likely to be found uncombined, so free in nature. The uses of this group of elements are wide and varied. They appear in almost every aspect of our day-to-day life, from electric cabling to decorative door handles to the jewelry that we're wearing. Many of these are important for life as well. Iron is in the center of a hemoglobin molecule. That's part of our red blood cells. Manganese and copper are involved in cellular respiration. That's what is tied to our breathing. So, in addition, these are the metals that are, used as metals. They're used in jewelry and construction. They're also called the heavy metals because of their... Just trying to lighten it up. This is a fairly long section. The inner transition metals do not occur in nature except for thorium and uranium. They're very unstable elements, and this includes the lanthanides, which are the silvery metals, and the actinides, which are mostly man-made radioactive metals. Note that this section or group of metals is the one that has been separated and placed at the bottom of your periodic table. Now, the lanthanides are used in movie projectors, high-intensity searchlights, lasers, and even in your tinted sunglasses. The americium is an actinide, and it's used in smoke detectors. So those are some examples of how you might come into contact with these inner transition metals. I like this comment. Rats! I thought lanthanoids and actinoids were going to be giant robots or something. So the rest of the metals are scattered around in several of the other groups, as listed on the slide. The group's name is given by the first element in the group, as you discovered when completing the periodic table basics activity in class. Aluminum is the most abundant metal and the third most abundant element in the Earth's crust. Gallium's so awesome it can melt in your hand, and it's used in semiconductors and lasers. Lead and tin are very similar to each other, except that lead is toxic. We use tin in the making of our soup cans, and lead is used in bullets. And then bismuth is commonly found in diarrhea medicines such as Pepto-Bismol. All right, the nonmetals. They are mostly gases and solids, except for bromine. Bromine is a liquid. There are 4 properties of nonmetals that we need to remember. Nonmetals are dull. They lack luster. Nonmetals are poor conductors. They don't allow the heat and electricity to flow through them. Nonmetals are brittle, and they shatter easily, so they're not malleable or ductile like the metals were. And the nonmetals like to gain electrons in order to achieve stability. So think about the halogens, which is group 7. We have not talked about it yet, but it has 7 valence electrons. It could gain 1 electron, and then it has 8. So when they do this, to become stable, they form negatively charged ions that we call those anions. So the nonmetals have tightly held valence electrons, which makes it harder for them to lose electrons, and that's why they'll gain. We're going to discover that all elements will gain or lose or share electrons until they have the 8 in their outermost energy level. And in fact, what they're trying to do is have the stable electron configuration of this group, the noble gases, which is the group 8A elements, the ones on the far right of your periodic table. The noble gases are colorless gases that are the most stable or unreactive of all the element groups. They exist as single atoms that have an octet, so they have a full set of 8 valence electrons, except for helium, okay, because helium only has 2. But they all have full outermost energy levels. Everyone wants to be a noble gas, and the noble gases have 8 valence electrons, so all the elements want to have 8 valence electrons. We're going to hear that 8 is great. That's something we need to remember. 8 is great. We're either going to lose to get 8 in our next energy level, or we're going to gain to fill up the current energy level that we have. And when I said next, I mean the inner one, the next inner one. So the low reactivity of noble gases leads to some special uses, such as in neon lights. Okay, so helium is the lightest of the noble gases. It only has the 2 valence electrons, and it's commonly found in blimps, airships, and balloons because it's lighter than air. That's why it floats. Neon is used in light displays that are commonly referred to as neon lights. Neon actually emits a pale orange light. Others used in neon lights include helium, which shows a pale yellow, and argon, which lights blue. Argon is the most abundant noble gas in the Earth's atmosphere. It makes up about 1% of the Earth's atmosphere. In fact, argon is used in welding, and then argon and krypton are both used to prolong the life of filaments in the incandescent lights in your home. I hate telling noble gas jokes. There's never any reaction. That's KimCat for you in this edition of Chapter 4 Notes. The halogens are the next group of elements of nonmetals that we're going to talk about. They're the group 7A elements. They all have 7 valence electrons, so they're going to want to gain 1 electron to become a negative ion, to have 8 valence electrons in their outermost energy level, so they achieve stable electron configuration. They're ideally suited to react with the alkali metals, which wants to lose 1 valence electron. They react with most metals to produce a salt. They contain most of the reactive nonmetals, which is the most reactive nonmetals is fluorine. It's the most electronegative element on the periodic table and is commonly found in toothpaste and in drinking water to protect our tooth enamel. This group of elements is also often used as disinfectants, such as chlorine. It is a deadly gas that reacts with nearly all elements, but it's commonly found in cleaning agents and used in sanitation. It can also be found in stomach acid. Most of these elements are diatomic except for Cl2. Now I'm not sure why it showed up as a big 2. It should be Cl with a subscript 2, so that lower 2. And then most of this group of elements is poisonous. And another interesting fact about some of these elements in this group is that less of bromine and iodine are produced each year. And iodine is needed to maintain a healthy thyroid and is found in seafood and table salt. So a very important element for us. The rest of the nonmetals are scattered around in several of the other groups as listed on the slide. The group's name is given by the first element, and the group is you discovered again when completing the periodic table basics activity. Carbon is one of the most important elements on Earth. The branch of chemistry that studies compounds containing carbon is called organic chemistry. The majority of all living organisms are carbon-based. Carbon is the basis also of fuels such as coal and oil, and it's a key component of steel that makes up our buildings. And diamonds come from carbon. And so does graphite. It's a very important element, carbon is. The last group that we need to talk about is the metalloids. They're found on the periodic table between the metals and the nonmetals, so it borders the stair-step line. A metalloid is an element that has some characteristics of both metals and nonmetals. So all metalloids are solids at room temperature, and they can be shiny or they could be dull. They are less malleable than metals, but not quite as brittle as nonmetals. And they tend to be semiconductors of heat and electricity. So they do conduct, but they are not excellent conductors like the metals are. This group of elements is often used in computer chips and in the making of calculators. Here are some pictures of silicon, which is an example of a metalloid, and showing you what it looks like in its raw or pure form, and then how it looks when we apply it to technology. So a silicon chip for a computer. And then, do I know the Spanish word for silicon? Sí, or the one I've already told you, what do you call a clown who's in jail? A silicon. A silicon. Alright, so the only one that we really have not even addressed is hydrogen, and then I need to go ahead and talk about helium a little bit more because these two elements are special elements. So hydrogen is the most common element in the universe. It is estimated that 3 out of every 4 atoms in the universe are hydrogen atoms. They are not officially part of a group. They consist of just 1 proton and 1 electron. Therefore, it behaves unlike any other element because it could have the electron traits of 2 groups. hydrogen is sometimes missing an electron, like the members of group 1A, for instance, and sometimes has an extra one, as in group 7A. So it either, depending upon what it's going to bond with, it's going to lose that electron that it has, or it's going to gain a second one to mimic helium. So helium, it's different from all of the other elements because it's very stable, having only 2 electrons in its outer energy level. Even though it only has 2, it is still grouped with the noble gases that have 8 valence electrons because of its stability. All right, that wraps up our conversation with the Section 2 notes. Make sure you have them all filled in, and we will talk about these a little bit in class next time. Thank you, and see you later.